Okay, here we're going to solve another rational inequality. Call our methodology. We are going to find the x values that make our function equal to 0, or the x values that make the denominator equal to 0. We put those on a number line and we test intervals. And recall the reason that our method is justified is because a rational function can only change its signs at its zeros or where the denominator is 0. So, first find the zeros by setting the numerator equal to 0 and solving for x. Here we get x equal to 1. We also want to find out where the denominator is equal to 0. Here, when we set our denominator equal to 0, we see pretty clearly that -2 and 3 are the only x values that make the denominator equal to 0. So we found the x values where our rational function can change sign. Let's put those values on a number line and test the intervals. On the right interval, we can test 4. It's a positive divided by a positive times a positive. Our function is going to be positive for values greater than 3. This interval we can test 2. We get a positive over a positive times a negative. So our function is negative in that interval. We can choose 0 as a test value in this interval, and we get a negative over a positive times a negative, which is positive. And the left interval, we can test -3, and we get, again, a negative over a positive times a negative, which is positive. We want to know where our function is less than or equal to 0. Our function is strictly less than 0 between 1 and 3. It's equal to 0 when x is equal to 1, so we are going to include 1 in our solution, right? Because 0 is less than or equal to 0. 3, you'll recall, got on our number line because it made the bottom equal to 0. So 3 is not in the domain of this function. Therefore, we will not include it in our solution.